You observe this is question number 5 in exercise number 1.1 Relations and Functions chapter. If you want earlier problem solutions, please find the playlist Relations and Functions class 12th Mathematics. Okay, you observe this question. In this question what they are asking, check whether the given relation is reflexive, symmetric, transitive. In these problems, we'll observe mainly 3 points. First, I'll write those 3 points. First point, this relation is defined on which set? You observe here, they given R. This is set of all real numbers. So, this relation is defined on real numbers. I written R here. This R indicates set of all real numbers. And this relation R is in R. That means R is a relation in R means R is a relation on R. It means that R is a relation from R to R. How the relation is defined? You observe this is important. The relation is defined like this. It contains an order pair A comma B such that A is less than or equal to BQ. Here you need to understand which order pairs are there in this relation. Here as R is a relation on set of all real numbers, A, B both must be real numbers. Okay, and the order pair A comma B must satisfy this condition A less than or equal to BQ. I'll take few examples here to understand this. For example, 1 comma 2. Is this order pair is there in this relation or not? First point, 1 is a real number. Second point, 2 is a real number. Yes, both are real numbers. Correct. Second point, is this order pair satisfying this condition? In place of A, you write 1. In place of B, you write 2. 2 cube means 8. 1 is less than or equal to 8. Is it true? Yes, 1 is less than 8. Yes, this is true. As this is true, I can say that the order pair 1 comma 2 belongs to this relation. I hope you are understanding. If I take 3 comma 3, the order pair 3 comma 3 is there in this relation or not? How to check? First condition, these two must be real numbers. Second condition, this order pair must satisfy this condition. You write here 3 is less than or equal to 3 cube. 3 cube is 27. Is 3 is less than 27? Yes, it is true. So what I can say from this, I can say that the order pair 3 comma 3 belongs to the relation. Like that, you need to know which order pair is there in this relation. Now you know what type of order pairs are there in this relation. Now we are going to check this relation is reflexive or symmetric or transitive. First, I need to check this relation is reflexive or not. What is reflexive? For every x in a set of all real numbers implies order pair x comma x is there in the relation, then we say that relation is reflexive relation. Here, when it is not reflexive, giving counter example is the easiest thing, right? Here what I'll do, I'll take one real number such that x comma x does not belong to the relation, so that I can say that the relation is not reflexive. Here I'll try to find one example which is not satisfying this condition. I'll take 1 by 2. 1 by 2 is a real number? Yes, 1 by 2 is a real number. Now I'll check that order pair 1 by 2 comma 1 by 2 is there in this relation or not. I'll check this order pair is there in this relation or not. First point, 1 by 2 is a real number. Yes, 1 by 2 is a real number. Now, is this order pair satisfying this condition or not? You substitute, in place of A you write 1 by 2. In place of B also you write 1 by 2. What you will get? 1 by 2 is less than or equal to 1 by 2 whole cube. 1 by 2 whole cube is 1 by 8. 1 by 2 means you know it is 0.5, less than or equal to 1 by 8 means 0.12. Here 0.5 means 0.50. Now you observe, is it is true or false? 0.50 is less than 0.12? No. Is 0.50 equal to 0.12? No. So clearly we can say that the order pair 1 by 2 comma 1 by 2 does not belong to the relation. I hope you understand. Actually, for any x belongs to real numbers, I need to show that x comma x belongs to R. Then only I can say it is reflexive. But here I identified one real number which is failed to satisfy this condition. So I can write that this relation is not reflexive. How to check symmetry condition? You take one order pair. For any order pair x comma y in the relation, if order pair y comma x also belongs to the relation, then we say that that relation is symmetric. Here, this relation is not symmetric. So I'll try to prove that this relation is not symmetric with the help of an example. Here it is not easy. You need to check, you need to take so many examples. You need to check. Here I am writing it directly, but when you try this your own first time, it is not so easy to find examples, right? However, for symmetric it is okay. I'll take one order pair in the relation 1 comma 2 in the relation. Now the point is this order pair 1 comma 2 is there in this relation? First point, 1 is a real number, 2 is a real number. Substitute this order pair in this. In place of A you write 1, in place of B you write 2. 2 cube, 2 cube is 8. 1 is less than or equal to 8. Yes, 1 is less than 8. This is true. So I can easily say that the order pair 1 comma 2 is there in the given relation. Now I'll check that the order pair 2 comma 1 is there in this relation or not. When I can say the order pair 2 comma 1 in this relation, first point 2 is a real number, 1 is a real number, because this is a relation on set of all real numbers. Now I'll substitute 2 comma 1 in this. Substitute. In place of A you write 2, in place of B you write 1. 1 cube is 1 only. You observe, is this is true or false? 2 is less than 1. 2 is less than 1? No. 2 is equal to 1? No. So we can easily say that the order pair 2 comma 1 does not belongs to the relation. 1 comma 2 belongs to R, but 2 comma 1 does not belongs to relation, as this element fails to satisfy a symmetric condition. I'll say that this relation is not symmetric. Here, finding such type of examples is the task to you when you try the problems your own. How to check the transitive condition? First, I'll take a pair of order pairs like this. X comma y belongs to R and y comma z belongs to R. Later, I'll check that order pair x comma z belongs to the relation or not. If order pair x comma z belongs to the relation, then I say that that relation is transitive. You observe, I need to find a pair of order pairs. I'll take like this, 10 comma 4. You need to check this order pair 10 comma 4 is there in this relation or not. 10 is a real number, 4 is a real number. Yes, this order pair 10 comma 4 satisfies this condition. In place of A you write 10 less than or equal to, in place of B you write 4. 4 cube 64. Yes, so 10 is less than 64. Clearly the order pair 10 comma 4 belongs to the relation. Now I'll take one more, like this ends with 4 na? So whatever I'll take, it must starts with 4. I'll take 4 comma 2. 4 comma 2 belongs to the relation. Now you check 4 comma 2 is there in this relation or not. First thing, 4 is a real number, 2 is a real number. This order pair 4 comma 2 satisfies this condition. In place of A you write 4, in place of B you write 2. 2 cube is 8. Is 4 is less than or equal to 8? Yes, 4 is less than 8. So this is true. So the order pair 4 comma 2 also belongs to relation. So I identified there is a pair such that x comma y, y comma z. See, x comma y, y comma z. I identified a pair. I need to check 10 comma 2 is there in this or not. 10 is a real number, 2 is a real number. Now this order pair you substitute in this. In place of A you write 10, in place of B you write 2. 2 cube is 8. Is 10 is less than 8? No. Is 10 equal to 8? No. So this is false. So from this we identified that the order pair 10 comma 2 does not belong to the relation. So what happened? This failed to satisfy transitive condition. Therefore, I'll write that this relation R is not transitive. Therefore, the given relation is neither reflexive nor symmetric nor transitive. Now, let's see one more question in this exercise number 1.1. Show that this relation R on this set, and the relation is defined like this, is symmetric. This relation is symmetric but neither reflexive nor transitive. That we need to show. Okay. As usual, first we'll write first 3 points. This relation is given on this set. Na? They didn't name this set. I'll name this set as A. Let given set as A. And they given that R is a relation on A. And the relation defined like this, order pair 1 comma 2, 2 comma 1. Okay. Now I need to prove that this relation is neither reflexive nor transitive but symmetric. Okay. One by one we will check order wise. First we will check that reflexive condition. What is reflexive? For every x in set A implies order pair x comma x belongs to the relation, then I say that that relation is reflexive. For every x in A, here this is 1 is there in set A, na? You look 1 comma 1 is there in this relation? No. So what I'll write here, for 1 belongs to set A implies the order pair 1 comma 1 does not belongs to relation. That implies the relation R is not reflexive. The relation R is not reflexive. Now I'll check symmetric condition. What is symmetric definition? For every order pair x comma y in the relation, if order pair y comma x also is there in the relation, then we say that relation is symmetric. Now you take here the order pair 1 comma 2 is there in the relation. For order pair 1 comma 2, reverse order like y comma x means 2 comma 1. You check 2 comma 1 is there in this relation. Yes, here it is. 2 comma 1 is there. Okay. For order pair 2 comma 1, 1 comma 2 is there. Yes, here it is. That means what happened? For every x comma y in the relation implies y comma x also belongs to the relation. Therefore, the relation R is symmetric. You observe how I written the answer. I written the answer in the form of definition. Here you cannot write like this. 1 comma 2 belongs to R implies 2 comma 1 belongs to R. That implies this relation is symmetric. If you say like that, that is wrong. You need to write every order pair in the relation x comma y comma x also present in this relation. Therefore, this relation is symmetric. So many students confuse in this. When it is not reflexive, you can give example like this. When it is reflexive, then you cannot give example, counter example. Okay. Now we'll check transitive condition. See, for a transitive condition, if you observe, they are asking us to show that this is not transitive. So, not transitive means you try to find x comma y comma z in the relation such that x comma z does not belongs to the relation. You look here, this ends with 2, this starts with 2, right? So, there is a pair like x comma y comma z. So, here I will write let 1 comma 2 is there in the relation and 2 comma 1 is also there in the relation. That means there exists a pair which satisfying the condition x comma y comma z. Look for x comma z. What is x comma z? 1 comma 1. You observe the order pair 1 comma 1 is there in the relation. No, 1 comma 1 does not belong to the relation. That means this pair fails to satisfy transitive condition. Therefore, R is not transitive. So, this relation is not reflexive. I'll take it as 1. This relation is symmetric. I'll take it as 2. This relation is not transitive. I'll take it as 3. From 1, 2 and 3, we can say that R is symmetric, but it is neither reflexive nor transitive. I hope you understand solution of this problem. If you like this video, please drop a like. Share this video with your friends. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye-bye.